Today's lesson is on sketching polynomials. Graphs of polynomials are smooth and continuous. This is an example of a graph of a polynomial. It has no sharp corners or cusps, which could look like this. See, it has a sharp little point. It has no gaps. This is a gap right here, or holes that can be drawn without lifting pencil from paper. So this is not an example of a polynomial. This is an example of a polynomial. Steps for graphing a polynomial. We have to determine what's called the left and right hand behavior, sometimes referred to as the left and right end behavior, by looking at the highest power on x and then the sign of that term. So if we're talking about the left hand, or sometimes I call it the left end, the end of the graph behavior, and the right end of the behavior, end of the graph, the degree of the polynomial, along with the sign of the coefficient of the term with the highest power, will tell us about the left and right hand behavior of a graph. So let me just stop for a minute and mention a couple of things. So let's say that we had f of x equals 3x squared minus 5x plus 1. The highest exponent, because that has a power of 1, this would be the highest exponent. So this means that this polynomial has a degree of 2. So we'll be looking at the degree of the polynomial, and then we will also be looking at the coefficient for that term and whether it's positive or negative, and that will help us. All right, this is a lot of information right here. So I'm going to kind of just talk through this. Basically, if we have an even degree, let's say that our degree is x squared, or x to the 4th, or x to the 6th, an even degree, then what that means is the left end, or left hand behavior, and the right hand behavior will both be going in the same direction. They'll either both be going up, like this graph, or they'll both be going down, like this graph down here. Now, if we look in front of the degree, and let's say we have a positive number like this, 5, or it could be any number, but if it's positive, then what that means is the right and left end behavior are going up in the positive direction. If in front of the x squared, or x to the 4th, or x to the 6th, we have a negative like this, that means the left and right end behaviors are going downward. Now, let's talk about if our degree was not an even number, like maybe we had x to the 3rd, or x to the 5th, or x to the 7th. Those are odd degrees. Remember, these are the degrees that we're looking at. They are odd. And so if they are odd, then what that means is the left and the right end behavior are going to go in opposite directions. See, this one is going down and this one's going up. Look at this graph. This one's going up and this one's going down. So they're going in opposite directions. Now, how do we know if we're graphing it this way or this way? Well, that's when you go and look at what the coefficient is. If the coefficient in front of the term for the degree is positive, then the right hand behavior is going to go in the positive direction. If it was a negative out front, then the right end behavior would be going down. I think this is wrong. Odd degree polynomials rise on the left and fall on the right hand sides of the graph. Like, okay, so that really probably should have a negative right here. Like if it was negative x to the 3rd power, then the right hand would be going down. So notice that basically I'm only talking about the right end behavior of the graph. So if it's a positive coefficient, the right end goes up. If it's a negative, the right end goes down. Well, you might say, well, then what do I do with the left side? Well, we already know it has to go the opposite direction. So if the right end is going up, then the left end has to go down. If the right end is going down, then the left end has to go up. And we know it's going in an opposite direction because the degree is an odd number. Odd number, opposite direction. All right, a few things to look at when we're getting ready to graph a polynomial, okay? These are just some graphs we can look at. A linear function is just going to have a degree of 1. That's when we just have something like maybe f of x equals 4x plus 6. See how it has just an x to the first power, that's just a degree of 1. So it looks like this. If we had an x squared, if our degree was a 2, then this is what our graph would look like. So this is talking about how many turns we have. So basically what you do is you find the degree and you subtract 1 from the degree, and that tells you how many turns there are. So see, this has a degree of 1. Well, if we subtract 1 from 1, we get 0. So that's why there's no turns. It's just a straight line. If this has a degree of 2, 2 minus 1 would be 1, which means we have 1 turn. See how it's decreasing and then it turns and goes to increasing? That's 1 turn. A degree of 3 would mean we have 2 turns. See, it's increasing, then it turns to decrease, and then it turns to increase. So there's 2 turns there. A degree of 4 will give us 3 turns. 1 turn, 2 turns, 3 turns, and so on. So here's some functions. They're written in standard form, and we are being asked how many turns there are. So I want to write a few things down. So first of all, in this first function, we can see that we have a degree of 4. So make a little note that the degree is 4. And so if the degree is 4, how many turns do we have? Remember, we have 1 less. So 1 less than 4 would mean we have 3 turns. Look at the next one. What would the degree of the next one be? We've got x to the first, but this is higher. So our degree is 2. Well, 2 minus 1 means we have 1 turn. The next one, what would the degree be? It would be 4. So how many turns? 4 minus 1 means we have 3 turns. The next one has a degree of 2. So therefore, 2 minus 1, we have 1 turn. And then this one, we have a degree of 4. Well, how many turns would we have? 3 turns. And our last one, we have a degree of 3, which means we have 2 turns. So that is helpful as we're getting ready to sketch graphs. Okay, something else that's helpful when we're sketching graphs is that we know where the graph is going to cross the x-axis. So if we could find the x-intercepts, that helps us. Well, when the function is written in this way, this is factored form, which we haven't learned how to go from standard form to factored form, so we just have to deal with what's given to us for right now. But if it's in factor form, it's very easy to take these factors and find where the graph is going to cross the x-axis. So real quick, if we just stop for a moment and we think about a graph, this is our x and our y-axis, and we were to think about points that are on the x-axis, what do they all have in common? They all have a y value that is 0. So all of these have an ordered pair where the y value is 0. So what I'm saying is we could set this equal to 0 because f of x is the same thing as having y equals. And then what we do is we take each parenthesis individually and we set them each equal to 0. So if we take the first one and say x plus 3 equals 0, we would solve that by subtracting 3 on both sides, which gives us x equals to negative 3. And then if we take the next one, which I'm kind of running out of room, so I'm going to go over here, 2x plus 1 equals 0, we would solve that. Basic equations. So x equals negative 1/2, or if you want to write negative 0.5, it's the same thing. And then 3x minus 1 equal to 0. So x equals 1/3. So we have negative 3, negative 1/2, and positive 1/3 as 3 locations where this polynomial will cross the x-axis. And so that will help us. We already know about the right and the left end behavior of the graph, but this tells us where it's going to cross the graph. So if you want to pause this for a moment, and if you would, go ahead and try p of x and f of x and see if you can find the x-intercepts, and then start this back up so that you can practice. Okay, so let's see what you came up with. So if you set each of these equal to 0, you would have gotten x equals 2, x equals 3, and x equals negative 4. On this one, you would have gotten x equals negative 3, x equals positive 6, x equals negative 4, and x equals positive 2. Steps for graphing a polynomial. Join the points together in a smooth curve, touching or crossing zeros depending on multiplicity, and using left and right hand behavior as a guide. We're not really going to worry with this part right now. We're just going to make sure that we get our left and right hand behaviors correct and that we cross the zeros or the x-intercepts in the correct location for right now. Okay, so since we're just getting started. Okay, so steps for graphing a polynomial. Determine the left and right hand behavior by looking at the highest power on the x and the sign of that term. Okay, so see how we have x to the first, x to the first, and x to the first? That means this is a cubic function. So therefore it has a degree of 3. So remember, when we have an odd degree, the ends go in opposite directions. Okay. The next part says, so we know the right end's behavior are going to go in opposite directions. Determine the maximum number of turning points in the graph by subtracting 1 from the degree. So if it has a degree of 3, that means it's going to have how many turns? 2 turns, so that's helpful. Then we're going to find the zeros by setting polynomial equal to 0 and solving. So we're going to take x plus 4 and set it equal to 0. That gives us an x-intercept of negative 4. We're going to take the x plus 2 and set it equal to 0. That would be negative 2. And the x minus 6 equal to 0. And that would give us 6. It says join the points together in a smooth curve, touching or crossing the zeros depending on the multiplicity. Okay, and using left and right hand behavior. So first thing I want us to do is I want us to go plot these points. So we've got the negative 4 for the intercept. So I'm going to go to negative 4 and I'm going to put a dot. I'm going to go on the x-axis to negative 2 and to positive 6. So those are my intercepts. So I know that I need to go through those points. Okay. The next thing I want to think about is my degree. Now, out front of this function right here, that's just a positive one. It's not a negative one, it's positive. So that means that the right end is going to be going in the positive direction. Remember that if it's an odd degree, that tells us our right end. Well, if the right end is going up, then the left end has to go down because they're supposed to go in opposite directions. And you got to curve it a little bit like that. And then you just kind of follow along. It's got to go up. Now you might say, well, how far? Well, we're not going to worry with that for right now. We're just doing a sketch. And then it comes down, and then how far down? Doesn't matter right now, and goes back up. Now, it really does matter on how high you come and how far down. But for right now, our focus is the intercepts and the left and the right end of behavior. And so this is our sketch for that graph. Okay, let's try the next one. Okay, so we look at our x's, and so this is going to be an x squared. We have 2 of them. So that means since that degree is 2, that's an even degree. So the ends go same direction. They go in the same direction. We also know because of the negative out here that they are going to both point down. We can take what's in parentheses and set equal to 0 and solve to find our intercepts. Okay, so if I go to negative 3 and put my dot, and positive 3 and put my dot, and then basically I already know that these are supposed to both be going down like that, and there's only going to be one turn because remember we take the degree minus 1. So that means it's going to go like this. Now, does it go all the way up to the 4? Does it go to 6? Does it go to 20? We're not dealing with that right now. Okay, we just are looking at the shape of the graph and the intercepts where it crosses. Okay, so if you want to pause and try this one on your own, you can. If you want to follow along with me, I'm okay with that. So our degree, those are ones. This is a x to the 4th degree, so this is an even degree, which means our right and left end behavior are going to go in the same direction. They're either both going to go up or both going to go down, so we look out front. This is positive 1, so that means our ends are going to go up. Better erase this arrow here, you might get confused. That means the ends are going to go up, so we know that. We're going to find each of our zeros. You may need to pause this while you work because I am working through these kind of quickly. But I think you should know how to solve equations pretty easily. Okay, now we've got our x-intercepts. All right, so we go put a dot at 1, we put a dot at -1, we put a dot at -5, and at -7. Okay, we know that both ends are going to be going up. All right, so we just have to follow through. This is going to turn around at some point. It's going to have 1 turn, it's going to have 2 turns, 3 turns, because it's got a degree of 4. Remember, you subtract 1 and that tells you your turns. So there's 3 turns, so that's what that looks like. Okay, feel free to pause it and try this one if you would like. This is a cubic function, so how many turns are we going to have? 2 turns. Also, because it's an odd exponent, that means they're going to go in opposite directions. Since we have this negative out front, that means the right end behavior is going to go down, which means it's going to look something like that, because cubics always have just the 2 turns, so it looks like something like that if the right end has to go down. If you find each of your zeros, and I'm just going to show them, you definitely should be doing the work. So if you set each of them equal to 0, you should get that. We'll put those dots on there. Okay, and then we know that the right end is supposed to be going down, which means the left has to go up. There's 2 turns, so it has to turn once and twice, and there you go. All right, something else that would have been helpful, and let me just go back and kind of show you on here. It definitely would be helpful when we make this turn, since it's crossing the y-axis, if we knew where it was crossing, like how high up. Are we going up through the 6? Are we going to cross at the 3? You know, where are we going to cross before we turn back down? So that's this next step, is looking for the y-intercept. We can put a 0 in for our x. So if we're trying to find the y-intercept, we can put a 0 here for all of these, and look what happens. Really what happens is all of this zeroes out and you're just left with -2. So that would be a y-intercept of 0, -2. And if we did the same thing here, plug in all of our zeros, we would end up with a y-intercept of 0, -2 for that one. This one would end up with 0, +1. Do you notice that basically everything is going away except for that constant at the end? Okay, so this one would be 0, -29. It's very easy when it's in standard form like this. These all would just make zeros. This would be 0, 0, and this would be 0, 2. So let's use that information and the things that we've learned to help us here. Okay, so notice that this one has a degree of 3. That means that the ends are going to go in opposite directions. Well, if you look at A, B, C, and D, they're all going in opposite directions. So that's kind of easy. If you look out front, this is a +1. So that means the right end needs to be going up. So which ones can we cancel if the right end has to be going up?
P and D.
B and D, that's right. We can cancel those. Okay, so what we can also do to narrow it down between A and C is we can look for the y-intercept. So if we plug 0 in for all of these, we'd be left with negative 42. So it has a y-intercept of 0, negative 42. Well, if you look at this graph right here, it's crossing the y-axis at 0, negative 6. And then it continues. It's going to keep going back up and going down. It's never going to come back across the y-axis. So it can't be this one. Now on this one, you don't see it cross the y-axis, but eventually, as this continues to go lower, it is continuing to go further this way. So at some point, it is going to cross the y-axis at negative 42. So the answer is C. Okay, let's look at the next one. Again, this is the same type of degree. The right end should be going down. So which ones can we eliminate if the right end's going down? We can eliminate these. It's going to have a y-intercept of 0, negative 4. So which answer does that look like? It should be C, because see how it's crossing here at 0, negative 4? All right, this last part, you are going to match the graph with the function. So if you would pause this and see what you can do as far as matching them up and then turn it back on, that would be best for you to get some practice. Okay, when I look at all of these graphs, this is a cubic, it's got 2 turns. This is an x squared because it just has 1 turn. This has got to be just an x because it doesn't have any terms. This has 2 turns and this has 2 turns. So these 3 are cubics. This is a quadratic and this is linear. So I think you could probably go ahead and say, well, this one would be D, right? It would be D. That would be a line because it has a power of 1. Notice it starts at 3 and then it has a slope of down to right 1, down to right 1. See how it lands on the line? Okay, so that would be D. We know that this should be C because it has a degree of 2, so it only has 1 turn. Another thing we know is that this has a y-intercept of 0, 3, and see it's sitting at 0, 3. So that's helpful. All right, now we're left with 2 cubic graphs. The difference is that this one has a, oops, I shouldn't have done that. This has a negative and this is a positive. So this first one, the right end behavior should be going down. It should be pointing down. And look, the right ends are both going up on here. So this must be A. And it has a y-intercept of 0, 3. See how it's crossing at 0, 3. And then this last one is either going to be E or H. So if we plugged zeros in here, it's going to have a y-intercept of 0, 0. And between E and H, the only one that has a y-intercept of 0, 0 is H. So this should be letter H. Okay, very good. That is the end of this.